Hello, everyone, and we are back here with the latest episode of Expert Insights Live. I can see a lot of people have already started commenting over here. We've got Fatima, who said she's looking forward to this session. I hope you're live here, Fatima. So if people can just confirm that all of you can see us, that would be great. I can see that we've got a bit of a lag. I can also see there are other people. Oh, there are people wondering where the LinkedIn live session is going to be. So the session is going to be live right here. You don't have to go anywhere else. You can see me. I'm Tushar, a senior product manager at Pact. We've got Dennis on the other side. Hi, Dennis.
Hi, Tushar. Thanks for inviting me.
Yeah, we've got a lot of people over here asking about the link. Hi, Jackie. This is the link. This is where the session is going to happen. So yeah, excited for the session coming up. So Dennis, may I ask you to introduce yourself? I know a lot of people know you, but still, let's do formalities and introduce yourself. Who are you, Dennis? What
Okay,
do you do?
my name is Dennis Rothman, and I started artificial intelligence in the 1980s. I registered a patent, an encoding patent, and then a chatbot patent with robotics. And then my first customers were LVMH, the luxury corporation, and what is now Airbus. And from those two references, it got me through decades of AI without really having to look for customers all the way up to Disney and other corporations like Air France. And then at one point in 2017, a person called Tushar Gupta said, Dennis, why don't you share your experience? Why are you sitting there alone on LinkedIn? Why don't you write a book? And I said, okay, it would be a good idea to share my experience and research with people. And since I like Tushar, I wrote a book, then another book, then another book. And here we are with Transformers for NLP.
Perfect. And so, Dennis, while we're waiting for everyone to add in their questions, so just to inform people, we have a couple of giveaways during the session. As you can see, the ticker going down at the bottom. Just comment with hashtag packed, and we'll do a couple of raffles, and the lucky winner will get the book. Also, there are four lucky winners that Dennis has chosen over the last week and a half. He had a couple of questions going on LinkedIn, and the people who answered the closest or the right answer, Dennis is going to announce their name and also share the actual answer. So all the
You want
best
me to
for
do that
that.
now?
Oh, you can start with the first one. Yes.
Yes, that way, while we're waiting. The first question I asked was, why would Hugging Face be the best solution in a given situation? Why not use OpenAI or other systems? And the answer was very simple, because you can download Hugging Face, you can go offline, and you can go into put it on a classified server, since it's forbidden on in aerospace corporations to communicate with unclassified servers through APIs. So the first winner was Carol Garon. Well, let me show the picture here. Yeah, it's a good idea. Here we go. See this beautiful man, handsome man from Poland? He's winner number one. Then
Congratulations, Carol.
winner number two, for the same question, saying you can't go from a classified server to an unclassified server. That's why you have to download Hugging Face or a similar system, is Guilherme Augusto Pochi from Brazil. And here is this handsome researcher from a nice research laboratory, and he just answered out of pure logic.
Wow,
Then I had a,
congratulations, Guilherme.
you want me to, so the second question was, what about the reverse? In which situation can't I use Hugging Face? And I'll absolutely need OpenAI, and I need it for high dimensional. When things are high dimensional, maybe I have like 10,000 features. I need a very powerful engine. So I wanted to use the embedding engine from GPT-3 called Da Vinci Similarity, which is an engine. You have the GPT-3 model, and then you train it to be an engine with 12,288 dimensions. And you have Raj Arun from India who won the first one here. Let's get right.
Raj is on a roll. This is my third LinkedIn live session, and he's won an ebook on each of the sessions.
He
Congratulations, Raj.
is a mastermind because he loves these quizzes. So he likes to answer all these questions. We had a lot of fun answering. In fact, he answers all of them. And he answered very well. And then the second
Brilliant.
person that answered very well is Safi Uri Azim, okay, who is from the United Arab Emirates. And here is his very intelligent face, staring you right in the eyes and giving you the correct answer, okay? Da Vinci simulatory embedding with nice explanations. So these are the four winners, very nice people, researchers, nice community.
Congratulations to all the winners. If you can just contact Dennis, or you can get in touch with me, and we'll organize the free ebooks for you. That was on the question. We'll also have the two giveaway raffles later today during the show. So all the best to all of them. And I can see a lot of comments coming in. Hashtag packed. Brilliant. If you have any queries, please feel free to add in as well. I can see a few people have already started reading the book. We've got Giovanna over here who's saying that this is a great book, amazing book. Sorry, her words, not mine. And the second edition is absolutely awesome. Dennis, there are other people who haven't started reading the book or who haven't got a copy of theirs. Can you inform all of us what is Transformers, why is it important, and what's new with this edition of your book? This is your second book on Transformers.
Okay, so the first thing we need to realize is that transformers are a new technology, right? It's only a few years old. And the first person who detected this technology is called Tushar Gupta. He is the visionary who saw this topic and he said, why don't you look into it? And at the time I looked into it, there were absolutely no books. Okay, I had to read all the papers. And just to fast forward to the second edition, okay, there are two things that are very special, okay, that you really have to get into mind. First is the model, okay, not the engine, the model, the architecture. The architecture is organized so that you can split your calculation into little blocks that are called heads, and you can run them at the same time in parallel processing. And then in the same architecture, you can go all the way up. There's the attention heads. Okay, these are divided. But now these days, and it answers millions of questions I get, you have a feed-forward network that is split now into a mixture of experts, which means that you don't need to use all the parameters. So you can easily go up to 1 trillion parameters using only maybe 11 billion parameters at the same time. So you can have a small model going through. So you can run in parallel, and with deep speed, you can also run the layers in parallel. So you have the superpower system, and inside it's just matrix multiplication, and you have NVIDIA GPUs that are designed for that, and you have Google TPUs that can do that. We can go in deeper later. Now, what happens with that? With this kind of architecture, you're not doing recurrent calculations anymore.
Mhm.
You're just comparing all the words among themselves, which means that you can train like on 1 trillion tokens. If you train on 1 trillion tokens, now we get to the second aspect. The first aspect was the architecture with the hardware. Now we get to the engine. Now, once you train it on 1 trillion tokens, there's a phenomenon called emergence. It means that it's not like your traditional training where you have a training data set and you have a test data set. No, it's going to learn the language. It's going to
Mhm.
learn the language, and it's going to learn how to do tasks that you don't even know it can do. That's what the big ones are for, like GPT-3 or Google BERT, not the Google BERT you get on Hugging Face, the Google BERT that Google uses. Okay, these huge models. And what happens is they can just do things that no one knows about. You'll discover it with a prompt. So in our second edition with Tushar, we really wanted to have an open book. We didn't want to focus on just GPT-3 or just Hugging Face or just the, no, we wanted to give you, the readers, a wide view. Like what? Learn all these architectures, Hugging Face, OpenAI, Google Tracks, Allen. Learn them, and then also learn different models: T5, BERT, GPT-3, Elastic, and more. And that way, you're ready to face any customer or any employer. Otherwise, you're going to be locked up into a system. So, with this broad view we had in mind, well, we're delivering another monograph on transformers with an open mind. We're not trying to convince you. There's no ideology in it, just science. Learn the models, and don't worry, the market will choose the right one for you.
So that is again, someone has asked the same question, and I think while they were asking it, you answered it already. What's the difference between the
Well, I
second
could
edition
add
and the
a
first
couple of
one?
things. What's
Yes.
different? Okay. So in the first edition, I was really focusing on getting the first monograph, the first book on the market with Tushar. Okay. Don't never forget the editor. He's the one that sees the market and guides you. Okay. So we were trying to get the right thing on the market. And the first thing for me in the first edition was focusing on all these papers because I had no books. So I had to read all these papers and test all these programs. And as Tushar and I remember, I had to debug some because they were
Hmm.
new. And I was writing them while I'm debugging this notebook. So there was a lot of programming. I was really focusing on the physical world of transformers and getting this broad view again. It's like GPT-3, T5, not get locked up in with one editor, platform, or system, so that you have liberty of choice. Now the second edition is built on top of it. I was saying, what if I added vision transformers? So in chapter 15, I begin to add vision transformers, clip, DALI. These combine images and text, images treated like text. So this brings more power. And also, OpenAI was ready to open up to everyone to use GPT-3. So I use absolutely everything that exists on OpenAI, from codecs, automatic programming, from embedding programs, content filters, instruct series, everything in there. So I bring that in the book, and every page I'm trying to make sure that you have an open mind, that you're looking at all the models, all the platforms, but you're still looking at Hugging Face because it's an excellent educational website, but still have an eye on GPT-3. Look at Google Tracks. Look at AllenNLP. Keep an eye on everything so that you can adapt. You can be flexible on the market. That is the key point. And in the last chapter, I insist on the meta-human aspect of transformers, that they're becoming so powerful when we're on as recommenders on YouTube, Google search is full of transformers, right? Google transformers. So they're smarter than us. They know us better, and they're able to make better recommendations.
Right. And I agree, Dennis. I never believe in a monopoly market. In a monopoly market, the reader or the consumer never wins. Having these options in the book really gives the readers an option to learn more, not limit themselves just with one platform. There are other platforms. Each platform has its pros and cons. Some platforms can do things better, some cannot do them at all. So that's one of the key USPs of this book as well. You're not limited just to a GPT-3 platform or just to a Hugging Face platform. Both of them have their cons and pros. But yeah, that's great. There is an interesting question that I found by Claude. Thanks, Claude, for asking this. A very simple question. What is the origin of the term transformers? Is it
Well,
coming from the
that, that
Japanese
that's
toys?
that was puzzling me. But in fact, when you think about it, it makes a lot of sense. Now, it's my interpretation, having worked on it for a few years now, is that if you take transformers, if you take the original transformer, you're going to have an encoder and you're going to have a decoder. Okay. And in this encoder decoder, you're going to have sublayers. Okay. The input embedding, positional encoding, and then you get to the attentions, the feed forward network, and it goes from layer to layer. That's the original one. And these are blocks. Remember, I told you can build. So imagine now you're talking about Lego blocks. just like children toys. And you take all these blocks and you just put them on a piece of table. You can really do it physically to represent it if you want to in a course. You can buy little blocks for children and you can build transformers like that. And then what you can do is if you just take, for example, the encoder out. Okay, you have two columns like in a game. You take that out, and now you just have if you take the encoder out and you just have a decoder, you have GPT-3. But suppose you take the decoder out, then you just have the encoder, you have BERT. Then you put both back together, and then you have T5. So you can in my imagery, because I'm not sure, but it's the best way to remember it, I can transform the original transformer into any part. But the thing is, when they invented the first one, they didn't know that it could be built in different ways. So maybe someone watched the movie, because I read the original paper, and one of the persons that wrote the paper is a really cool person who everyone's thinking big tech, but this was a very small team. And they were having a lot of fun. They were eating a lot of pizzas and drinking coffee. They didn't know where they were going. They were just trying these new things. I just think these are nice. These are people that had a lot of fun, and they say, why don't we use transformer, because we're transforming AI. So this is just my imagination.
Okay. I may have to do a little deeper research to understand where they actually came from. Claude, if you find the answer, please drop me a message on DM, or Dennis. I would love to know this. This is actually a very trivial fact, and I'm getting
Yeah,
quite curious
I'll
now.
do some research on it too.
Yeah, there is another interesting question. Here's one from Alexi. Alexi says, what is the most unexpected application of transformer that lies outside NLP that you're aware of? Wow, it
Yeah,
does quite a lot of things now.
that is a very puzzling one, because remember I was talking about emergence, and fortunately I'm also a computer vision guru. I worked a lot on it, and I followed a lot of courses, and I was constantly seeing the way I break up images. I worked on an image project a few years back, and all of a sudden I see this paper. You can treat images as text.
Hmm.
I say, wow, you mean we can process images and do image recognition like that? How does it work? So then I went deeper, and I saw that Google was working on their TPUs, because remember, Google is the corporation that invented transformers. They're working on TPUs, and they're saying, our TPUs, why don't we treat an image in a flattened way? We have 28 times 28. Why don't we just put it in 1784, this small grayscale image? Now that we have it in a sequence, why don't we consider it as a word? Why don't we take patches of images and say these are words? Okay, so they go to the next step. Since these patches of images that we're taking out are words, why don't we create a dictionary with them? Why don't we put a dictionary with them? And the way they go together is grammar rules. And then they go, okay. So then they go more in their experiments, and they begin to create the vision transformer. I say, so I'm reading this paper. I say, this is not possible. So then of course, in our book, I would say, because it's Tushar's book too, and it's also Pac's team book, there's a lot of people we're not mentioning here, like Babish and Karen. These people are working. The author's not alone. You're working in a team, okay, with people with hundreds of ideas. So I took the notebook and I said, I'm going to really test it at low level. So the book is, every chapter has a notebook. There's no such thing for me as theory without a program. That is just, that's PowerPoint presentations. We don't do PowerPoint presentations at PAC. We want explanations in code. So I ran the code and I say it works. So I'm taking an image, breaking it down into patches. These patches are fed into a dictionary, just like words. And then I'm putting them back together again. It's recognizing it. So that's insane. So then the next step is clip. So this is chapter 15, by the way. So in clip, I'm saying, what are they doing now? Oh, they're even putting these patches of images as a dictionary, and then another layer, a neural network layer of words. So now we're describing these images with words, and they're learning all these things together. I say, okay, they can't go further. Oh, they did. DALL-E. So now OpenAI came around with DALL-E and said, why don't we just mix it all up? Why don't we say that these patches of images are also words? And we put them all together. Let's feed the whole thing into there. So now it looks like a human mind, so that when we see the image of our house, we think house. And when we see pizza, we think pizza. Or we see hamburger, vegan, you can say vegan burger for the vegetarians. And so you see images. So DALL-E just said, why don't we just put it all in there? And in chapter 15, you get to this insane application where you just choose what you want. You say, I want a house with a bird on top, and you get the image. It'll recreate the image. So that is extremely surprising. Of course, I tested this with music. Maybe it's for another edition. I'm a musician. So I did a lot of playing on my music. I recorded it. I put it through computers and I fed it into transformers. And hallelujah, it creates music and it's continuing in my style. So I think there's no limit. There's absolutely no limit, since everything can be broken down into sequences. I
Yeah.
even did it on supply chains. Since supply chains we're speaking about, I took a lot of supply chains and I could predict the sequences, the things that were going to happen. So I don't think there's a limit.
Dennis, I'm quite intrigued by the fact that you mentioned supply chains. There is a question which came in, and I'll pop that one up first. And here's Amrit asking that can we use transformers for decision making?
Yes, I did that.
Have you used an
I did
example
that.
in the
In fact, I
book?
think it's a notebook. I did it either for a company, or it's a notebook in the book, or I'll put it in the bonus. What I did is I took, yes, this is true. Emirates, I've done this. I took a markup decision process and I created a markup chain with, I think that, yeah, I made some videos on YouTube on it. And I created a chain with a flow, a complete flow of sequences of supply chains. Okay. I did that in fact, in my first book, Artificial Intelligence by Example, in the blockchains. I used the blockchains to predict other blockchains. And then here in Transformers, you take sequences of supply chains with reinforcement learning. You can create synthetic data with expert system rules, and then the transformer can learn it and it can make predictions. In fact, in chapter 16, I think there's a notebook with embedding where I use the 12,288 dimensional engine in GPT-3 to create similarities in supply chain inputs, outputs in warehouses. So you can go pretty far with that. And I just want to tell something to everyone. You can learn anything you want, but when you go see a corporation, tell them how much they're going to earn with it. Like
Yeah.
I say, I'm going to optimize your sequence. You're going to earn that much money. It's just not doing things. It's how much, what is their payback, the return on investment. Never forget that.
Right. So, uh, since you were talking about the GitHub repo, what I've done is I've already added the book GitHub repo in the chat. So, if anyone is curious about what are the examples that are used in the book, please feel free to just, if LinkedIn allows and makes it clickable, you can just go over there and click it. If not, you can just come later on to the recording and find this comment over here, and you can simply find this. Claude had another interesting question, Dennis. What about the importance of self-supervised learning in training transformers? And
Yes,
this is right up your alley.
that's one of the mysteries I was talking about earlier. Is you just, if you're taking the original architecture, you're going to have an encoder, and before you send it to the decoder, it can just learn anything it wants. So actually, it's freestyle. It's just learning the relationships between words. Like if you have eat, then you know there's something going to, a noun that's going to come after it, like eat something. Or if there you have an article then you know there's going to be like a noun. And then if you have a verb, a transitive verb, there's going to be a noun. So it learns all these things, and most of it is just self-supervised, and some can be supervised, but I'm not sure that in the future we're going to need supervision anymore, because it's
Mm.
beginning just to learn all these patterns by itself, and then the way you write the prompt, it'll just continue the sequence. So I think that the future lies in a lot of self-supervised because we don't have time to create all these data sets. In fact, all these data sets are not that good. I can give you an example. Suppose you take supervised training. Like I had a post a couple of weeks back where Hugging Face, I really like Hugging Face. Okay, I want to say that first. I like Hugging Face. I like it for educational purposes, for small projects. But then they went to AllenNLP and they created a model called Macaw, a T5 model. Okay, and they say, wow, we have this small model, 11 billion parameters, and it does better than GPT-3 on our corpus. So they took a corpus. So they took their corpus and they did the supervised learning, but that's not the way to do it. So on the site, and they're very honest people, they work very well, but they just missed a point, which is the whole point of my book, is to learn all the models like an expert and not look at them from outside. So I went from
Yeah.
inside and I took a GPT-3 model. I took the Da Vinci one. I admit I took the most powerful one. And I didn't train anything, zero shot. I took their corpus, took the examples there, and I just did a zero shot. But remember, there are 10, you can have around 10 parameters for GPT-3 with about 3 or 4 values. So 3 times 3 times 3 times 3, that means thousands of combinations. So if you didn't learn it, how do you know how to use the zero shot? So I know how to use it just like someone knows how to play the piano or play chess. That's GPT-3, okay? So I did it, zero shot, and you got correct answers to that corpus with zero training. And I showed that all the answers that are on the website are not right because I didn't know what they used. They used a GPT-3 model. Which engine? I used the most powerful engine with the right parameters. If I took the worst engine, of course, it's like going to Indy 500 with a 1924 Ford. I used the latest one and I got excellent answers. So I think the future lies in a lot of self-supervised learning where the system just learns and learns and learns in this uncanny way through emergence, and then you pilot it with your prompts. You say, give me the answer to the question, and since it learned trillions of combinations, it will continue the answer.
Yeah. Dennis, your background really helps here as well because you've been consulting to these Fortune 500 companies for quite a long time. You've always had the habit of creating white box models or explainable models so that people can understand what's happening under the hood. And that's what you've done in this book as well, where you've taken apart each and every model and shown the readers the working of each and every single thing, what's really happening. So that leads me to the follow-up question, which lays really well over here. Uh, Raj inquires, the Transformers is quite an overwhelming and complex topic. So what can the readers expect? How accessible do you make it?
Okay, so that I did expect a tough question from Raj. I I see his mind ticking. I can hear your mind ticking, Raj. Okay, so this is a very difficult answer because we are talking about complexity, especially when I'm talking about emergence. So the first thing to know is that I'm a model agnostic person. Okay, I don't believe, you can feel that since the beginning of the session. I don't believe in any single model. I only believe in a model that fits the usage in a given corporation. So I don't go from model to market. I go from market to model. Now, the first thing that happens in a company is a user will not use it if the user doesn't understand how it's working. The user doesn't trust it. The user don't like us. They don't like us bringing change. They don't like the interfaces. They don't like the outputs. They can do better. So you need to explain how this works to the user. And to do that, that's one of the chapters we did in chapter 14, is that I did some explainable AI in chapter 14 in a model agnostic way so that you can see that this input goes to that output. Now I wrote another book called Explainable AI, and you can use the algorithms in that book because the whole 75% of the book is model agnostic, so you can apply it to everything. But I didn't answer the question. I just
Yes.
showed how I could give you the answer. Now, the only way you can do it is compare it to learning how to play music or learning how to play chess. You can always learn the rules of chess, and you can always learn the notes on that piano that's behind Tushar back there. Okay, that's a $100,000 piano down there. Okay,
Yeah, it's a virtual background. It's not my home.
yeah,
I wish.
he's pretending it's a virtual background, but in fact he's a billionaire and he's just sitting here. Okay,
Sad. If
so
only.
okay, no, it's a virtual background. So what everyone knows that everyone maybe has tried to play music, or maybe someone has tried to paint, or someone has tried to play chess, and you know that at one point, or learn a language, you know that at one point you forget the rules. You
Mm.
forget the rules, and you're the player. You're the chess player, piano player, musician, language, or in your job with queries. So you have to, that is one of the fundamental reasons I wrote the book that way, so that you see all the models through these different perspectives, through different ways of combining them with different prompts. And I'm using it as clay, and I'm trying to make your mind go in all these directions. So at the end, you can say, oh, I know how to play Transformers. I understand it. So it has to come from you. It has to come from you to be open, not to be locked up into one platform or one model or AWS or Google. No, you're gonna try it through all these combinations, like combinations of music notes or combinations of chess or combinations of colors. All these combinations, when you work on the book, conceptually will open your mind at some time you say, hey, I got it. I know how that thing works. So when it gives me a bad answer, I know how to change the prompt. So you can play around making prompts and see if you get what you expected. And if you don't, you just play with yourself. You can just dialogue and say, the system should answer that. And if it doesn't, maybe I should review my. So it becomes a game in the end. So you have to learn how to play and to have fun.
Yeah. Before we move ahead to the next question, I would just like to inform everyone in the excitement of all this conversation, I forgot to start collecting the comments in the raffle. So if you all can just add in the comments hashtag packed, your entries would be added in, and then we can do the raffle later on in the session. At this point in time, there is only one entry because I commented, please type in hashtag packed to enter the raffle. So please comment hashtag packed to enter the raffle. I'm really sorry. I was so excited about this conversation. I completely missed adding in that starting the raffle. Dennis, to while we're going ahead, what are the prerequisites of this book? Does someone have to be like an expert in natural language processing, or can they have like basic machine learning understanding and Python programming understanding to pick up the book and start learning transformers?
Okay, so you come after Raj, and then you ask another. You're like Raj. You ask another difficult question. There's two ways to look at it. Okay, there are two ways to look at it. There's one way, saying, the standard way, the publisher way, to say, be careful when you read this book. You can't be a beginner. You should know NLP and you should know all that. Okay, it might make it easier for 3 pages,
Mm,
but then there's the other side of it. Like, I hired a lot of people in my life for computer science, and I loved the developers with no experience, because I could format them in a very creative way. So let's suppose you don't know anything about it and you're creative. It might be fun, if you're not a beginner, to read it, because then you don't know the past. You're already in the future, because there's a problem with innovation. The Transformers came around 2017. By the time it reaches universities at a good level, it'll be this year or next year. Okay, just start. It takes like 5 years to change programs in universities. By the time the students get their master's degree and some work and some influence, that's 10 years. And by the time the general public understands that, the technology is already old. It's already gone. They're talking in the past. So if someone is determined, might say, hey, why don't I just jump into the future? I don't have to look in the past. And
Mm.
I'll just read the book. And when I don't understand something, why don't I just look on the web for an article on Medium or Towards Science or another book of fact and just pick out the definitions? The web is so powerful. And then you can ask me questions. You can say, why don't I contact Dennis on LinkedIn? He's going to explain it to me because I love giving explanations. And I often turn questions into posts.
Mm.
So either you can come in as an experimented developer, but you're coming in with the past. You have to forget that past. Or you can say, hey, why don't I just jump into 225 and just jump into there and have a lot of fun and bother Dennis with lots of questions, which I get
Oh, you
every day.
don't. Yeah, the readers don't even have to worry about bothering you on LinkedIn. For this book, we've created a specific Discord channel. So the people who purchase the book, they will see that there are links to join Discord, and there are active conversations going on there. So once you start reading the book, you can ask Dennis as many questions as you want, and he'll be more than happy to answer it. And if he thinks that your question can help a wider community, he might even convert it into a post on LinkedIn and give you credit for it.
Yeah, why don't you put Juanito's question on Juanito
Juanitos. Okay,
at
I
Julie
can't.
Loco?
Oh, yeah, I can see it now. Right.
This is a very important question because remember I said do not get locked into one model, do
Mm.
not get locked in one platform, but there's something that's certain is that parallel processing and breaking AI algorithm into little parts that you're training in parallel and you're training all the layers at the same time is something like Microsoft has been working on with deep speed and Google has been working on with their clusters. So what I'm telling you is at the end of the book, if you think just of the way the hardware is used, you are set for the future because the uh, computer processors are reaching their limit. We all know that. We're not in Moore's law anymore. We can't do that. It's extremely difficult. So what Google has done is they created their TPUs and then they created clusters of TPUs, like with 1,000 TPUs in them, that then the TPUs are very special. You can use 16 floating points or 32 when you need them. So you don't need that much precision for a lot of neural network training. So I would say the word technique, that's why Juanito, that's why I put I want it, it's the technique. The transformer model is opening a new era of saying, I'm not just going to write an algorithm, I'm going to write an algorithm that fits with the processors. Like if you do, I
Mm.
have PyTorch examples in the book. In fact, there's an appendix. There's an appendix in the book, appendix 2, where I explain this and I say, the transformer model is loaded on a NVIDIA processor. It's loaded on it physically loaded on it. And you can load it on in little batches all over the place. So you're going to learn a technique. Transformer, consider it as it is, the model, but as a method to use hardware that no doubt is the future of artificial intelligence.
It's just on the road to it. So, Dennis, before we take the next question, let's just do one raffle because we past the first half of the show. So let's do the first draw. A lot of people have entered in. I can see about 21 entries. I hope it does not pick me. It was just a comment. So the first winner is Kisale Shrivastava. So Kisale, if you can just drop me a message on LinkedIn, uh, I'll get the book organized for you. Congratulations. Just drop me a message on LinkedIn and I will get the book organized for you. And we'll do the second raffle in a bit. So if people can just continue adding in the comments, hashtag pack, that would be great. Dennis, do you want to have a sip of water before I ask you the next one?
Yeah, chapter 6 covers machine translation with Google Tracks. In the book, just go to chapter 6. and Google Tracks. Why did I use Google Tracks? I could have used Hugging Face. In fact, I think I showed a little example. It takes 3 lines with Hugging Face. It
Right.
also takes 10 lines with OpenAI. But I wanted to make you suffer. So I didn't give you that easy solution because after you know just from transformers, pip install transformers from transformers translation and translate this sentence. You can do the same with OpenAI, pip OpenAI, but what are you learning? You're learning nothing. So
Hmm.
I made it hard. Okay, so I put the notebook, and you can see the whole mess of programming that's behind it, and get the feel of an engine like a racing pilot who likes to open the hood and look at his engine before the race. So you get the feel of it. And then after, when you go to these easier interfaces on Hugging Face or OpenAI or AllenNLP, well, you can say, I know what's behind it. So chapter 6, machine translation.
Great. There is one from Bharat, and because you were talking about chapter 14 earlier, which has interpretable and explainable transformers, can it be used in healthcare?
Okay, so for healthcare, we have to be extremely careful when we touch this topic. First of all, this is my recommendation, high dimensional. Do not try dimension reduction on images of scanners, x-rays or things like that, because you might end up in prison or killing people, right? So
Yeah.
you want a high dimensional vector space, the highest possible. Okay, this is why that was one of the reasons of my second question with the quizzes. You used it like a Da Vinci similarity embedding engine with 12,288 dimensions so that you can manage this high dimensionality. And then what do you do with it? You take this embedding you did, and I did it in machine learning, and there's a notebook in the book. And what do? You feed it into a scikit-learn clustering program. So now you have this high dimensional clustering where you can say, well, this is a cancer, that's not a cancer, this is okay, or this is the DNA you're looking at. You need high dimensional, okay? Now, that's only half of the answer because I didn't tell you how to interpret it. Then you go to chapter 14, and then you can see it's model agnostic. So you can use any algorithm I show in chapter 14, or you can go back to hands-on explainable AI. And I have about 10 algorithms you can use in there that are model agnostic. Just remember that explainable AI, beyond developers that want to go look inside, is model agnostic. You take the input and it will analyze the output using SHAP, for example, saying, what if I take this out, I take that out, I put this in? It's just like when you were playing games as a child, you had 2 pictures and you had to find the difference. Well, that's, there's an ear missing or something. It's the same thing in model agnostic. Take the input, the output, you take things out, you see the difference. So you can use model agnostic explainable AI that's in that book or in chapter 14, which goes a bit deeper inside the models.
Great. There's another question by Anina, and she was wondering about the recommended techniques to leverage transformers on a small training set. For example, social media posts on a new topic.
So
I,
Anina likes to ask difficult questions too, because think of it. Think of this. Think of how hard you worked as a child and a young adult to learn a language and maybe a second language. And for people from India, for example, for learning 3 or 4 languages, okay, or Africans learning 3 or 4 languages. And just to analyze this little post on social media, it takes all that experience. If you give me a small, tiny post in Chinese, and I like Chinese. I mean, I like the pictograms. It looks beautiful. I like to draw them. In fact, it's even an art. I don't understand anything. I have to go through that. So if you want, if it's a small training set, it depends on the topic. And then if the topic is so general, you don't need training. You just go to GPT-3, OpenAI, and then you go to sentiment analysis, which is chapter 12 in my book, and you just use or a hugging face, and it just takes 4 lines. If it's general sentences, like I went to the movies and I didn't like it, and this and that, you can do that. Then, if you want to really train it, then you need 1 trillion tokens, just like you did. Because everyone's saying, yeah, but we only have 80 billion neurons. Sure, think of all the connections. You're talking about trillions and trillions and trillions. Every time if I say word, I'm activating thousands of neurons in my mind and thousands of connections. So I don't think there's anything simple. Now, if it's specialized like in law or something medical, even if it's a small data set, it's a problem. And then you get to our intelligence, where we can understand things that were implied. Like someone can say, you see in a tweet, oh, that was a good movie, but this and that, and the person thinks he's funny. And then the person says, ironically, in the next tweet, oh, that's funny. But in fact, the person is just making fun of the other one, saying, oh, that's funny. But the person is saying, no, that's not funny at all. It's just see our language, like, do you like that movie? And you can say, sure, I love it. Okay, how do you see that in a tweet or anything? So you need something pretty powerful to get the context. Now you have an Amazon Alexa that's working on intonations and prosody, but when you're reading a social media post, that is one of the big problems. Is you need a lot of context. You need to analyze everything that came before and after.
Yeah.
So I won't use. It's very complex. Let's not say it's easy. Okay. Now you can use a small training set, but I don't know what you're going to learn. Now you can fine tune a small training set with GPT-3. GPT-3 can be fine tuned. So you can load it. I explained that in chapter 16. You can load your small training set to OpenAI, choose an engine, and it will fine tune that huge engine with your dating set, your training set. That might be something interesting to try.
Great. And there is another one from Fatima. Being a starter in this field, what would your advice be on how to go about learning models and be an expert? There must be a tip or two that surely is going to change the game, Dennis. I know what your answer is going to be, but yeah, please.
Well, I'm going to tell you something pretty stupid. I would really go out. I would go out to a toy store, and I would buy a little box of Legos or of little building blocks, and then I would take chapter 2 of the book, and I would build the layers, because there are only 6 layers in the original model, so you just need 6 layers, and you only have 8 heads, so it's not that difficult. And then with the marker, I would go write what it is on it. And then when I get to the next chapters, when it's a different model, with these little building blocks, I would build it again in a different way. And then I get a physical image, because we're physical people. We lived in forests and jungles. We need visual. We can't just do math. So if you go through chapter 2 and you build it physically, and then in the next chapters you do it that way, and maybe try to explain it to your children. I love the way I test my books. This is a secret. I explain it to children that are 6 or 7 years old. Okay, and if they don't understand it, then I miss something. So I do this kind of thing. You can take glasses with water and make the data go from one glass to another. I've done that with children. Do something like that and spend a lot of time opening your mind on all these models and frameworks, like I've been saying since the beginning. Go through the different chapters and begin to have fun. Play with the notebooks, run the notebooks, have fun with them. You need to have fun with one point.
Yeah. I think for Dennis, for you, it's always about the learning journey and not the end point of being an expert. You haven't stopped learning, and I know that for a fact. You read so many
Expert,
research papers
I
every
don't.
single day.
I believe that anybody who thinks he's an expert, you can write it. I say I'm an expert, but if you believe it, well, you're not an expert anymore, because every day technology changes. So if every morning you're not learning something new, every morning I get up and I spend at least an hour or two trying to find what's new reading all these papers. And if you don't, well, then the train keeps going forward. And at one point you say, hey, I missed the train. So an expert is defined as a person who knows a lot and knows that she or he doesn't know anything and has to keep learning. That's an expert.
Yeah. All right, Dennis, we are really falling short of time. I'm not sure if LinkedIn will end the session. We'll take one last question, and then after that, we'll do the raffle. So here's the last question, and I know it for a fact that you're going to love answering this. So the last question is by Nitin Bisht, and he's inquiring if we've covered zero shot learning for NLP in the second edition. The main reason why he's asking is because India has more than 2 dozen languages, with each language having multiple regional dialects, and it does not create a corpus. Uh, so for such scenarios, it can be a nightmare. How can it be addressed? And I
Well,
know you love
Nitin,
such challenges.
the Nitin, the answer is in your question. It's a nightmare. You can't address it. There are too many regional dialects. And the main reason transformers are successful because they're working on the English language, and most of the world speaks English. The other country that does it pretty well is China because they have this huge population and a lot of data. And then the reason why in the original transformer model they use the French language for translation is that you have huge data sets data sets of the French language, which is spoken in Canada, Switzerland, Belgium, and a lot of places of Africa. So, Nitin, I would say the nightmare is for you because you're going to have to create corpuses. You're, it's. I think it's both very difficult, but I suffer a lot from this because these regional dialects contain concepts that go 1,000 years back and that can't be translated. There are ideas in there, customs, we're losing it. So one idea that came up in my last session with Hayat Santori, data scientist from Germany, we were thinking maybe why don't we take one of these dialects and go through everything that's in it that's original, the concepts that are only specific to this dialect. Like if you go, everyone knows that if you go to see some Eskimos at the North Pole, they have about 60. I'm just saying 60, but they have tens of words for snow. If
Hmm.
you go to the desert and you speak to the Bedouins, they have dozens of words for sand, for the wind. These are important cultural aspects. So I would say, Nitin, maybe you should go through the concepts that are missing in English and make a dictionary of these concepts so that we don't lose this culture and then translate them into English or spend a lifetime on one of the dialects.
Yeah.
And you know that we're speaking about India. There's Mohenjo-daro and Harappa that in the northwest of India that used to be. It's in Pakistan now. It used to be in India, and they had a language that's just like one of the. A lot of our civilization comes from those two cities. You know, the Indo-European culture, and then the language that spread out. German is an Indo-European language. French is too. English. All this comes from that place. But no one has managed to translate the little symbols that we found because the data sets are too small. So it is a nightmare because for me, it's a pity to lose culture.
Yeah. True. There are a lot of references that happens from our daily. Well, we don't speak the normal English in our daily life. There are a lot of slangs that are used as well, and I know it for a fact in India there are so many dialects. After every 10 kilometers, you would find a new dialect in
Yeah, but
India.
it's rich
Yeah.
because you have the
One
culture
last
that
question,
goes with it.
Dennis.
Yeah.
Yeah. One quick last question. We've got 5 minutes left, and we need to do a raffle as well. And Fernando has asked a very interesting question. What do you think about the high number of features used by transformers in NLP tasks? Is there any gap for optimization algorithms in the future, or will they push hardware development or something else?
Now, Fernando, I'm glad you asked that question because I was hoping to answer that question. This, and remember earlier in this conversation, I said you have big tech, and then the time it gets to the university, time it gets to the developer market, and then to mainstream, this problem has been solved. It has been solved with a technique called zero redundancy, and deep speed has solved that. That means that you can train a trillion parameter model with sparse modeling,
Hmm.
like an 11 billion parameter model. That means that I'm going to reach a level in the attention heads. Let's make it simple. And it's like you go to the movies, you're going to a big theater, and there are 10 movies. You can choose one of the movies. Now, old Transformers, when I'm saying old, I'm saying last year, okay? So old Transformers are going to look at the 10 movies. They're going to analyze all the features, and then they're going to go up to the next layer. Sparse modeling says, no, 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 no. I'm going to make a prediction right now. I'm going to make a little prediction. I'm going to find the smallest path in this sparse model, and I'm only going to use a tiny part of the parameters. I'm just going to focus on that movie because it seems to me that's one of these three movies I'm going to watch. When you go to the movies, you don't say, I'm going to look at all 10 movies. You say, I like that one, like that one. You're not going to look. I'm going there. So it does the same thing. So the future is sparse modeling, and as I said, hardware optimization, where you use less precision in the TPUs, so you don't need that much energy anymore. And remember, this is important. Google is now 100% sustainable energy. Microsoft is nearly there. These big tech people are not what you think. They're sustainable. We're the problem. My laptop is not going on sustainable energy. So I'm looking at solar panels right now because I'm getting this inferiority complex when I'm seeing Google. We're 100% sustainable, and we're always criticizing big tech, but we're not as good as them. So I'm thinking of solar. So there is no problem. Now, a second part of your question, Fernando, is optimization. Many optimization algorithms do not require transformers. You're not going to use transformers for rocket trajectory calculations. Okay, you're going to use physics, pure physics with scientific calculations. You don't need a transformer. So it depends what you're speaking about with optimization algorithm. It's transformers, I just answered it. If it's optimization algorithms, sometimes you do not need transformers at all. And if you do, you're taking a risk because it's probability, it's stochastic, and you don't send rockets to the moon with stochastic calculations.
Great. Uh, so, all right, we'll do our last and final raffle that we had. The winner of the first one was Kisalea, and he's already sent me a LinkedIn connection. I'll get in touch with him after this session, and here's the final draw. All the best, everyone. May the best man or woman win. Who is it? Maggie Bharat. Maggie, congratulations, Maggie Liu.
Maggie
If you
Lou,
can just
congratulations.
get in touch with me on LinkedIn, just add me as a connection or just DM me, and I'll get the book arranged for you. So congratulations, Kisalia, Maggie, and the four winners that Dennis announced. If all of you can just get in touch with either me or Dennis, I'll get the ebook arranged for you. Congratulations, everyone. Dennis, are there any final closing words that you would want to add? We've got a minute left.
Yes, I would say my final words is learn as much as possible in the book, but think of it as this game you were playing with a child with different blocks, and have fun. If you have fun, it's going to be a lot better because you'll be playing around with it. Just learn how to play with it. Don't get stressed. If the chapter is difficult, skip it. Go to the next chapter and then go back to that one later. Or something's difficult on a page, skip the page, run the notebook. And if you have a problem, ask me questions. Basically, enjoy.
Thanks a lot for that final words, Dennis. Thank you, everyone, for joining. All the best. And if you need any further queries, if you have any further queries, just feel free to reach out to either of us. We'll be more than happy to help you out. All the best until next time. See you soon.
Okay, bye bye.
Bye.